Okay, we're looking at a basic nightlight circuit using a parallel circuit and a Wheatstone Bridge diode and a photo eye. Now here's a physical look at what we're doing. Right now we just have this hooked to a basic 9-volt battery. This is so that it would be our power supply, and then what we do is you cover the photo eye. The LED turns on, pull off, turns off, turns on, turns off. So basically what's going on is if you look in here at this drawing, the voltage is coming with the actual photo eye to ambient light. We're reading as of right now at about 1K ohms. Let me put the K's over here. 1,000 ohms. So when we cover this up completely, we are reading at about 30,000 ohms. So with this being 30,000 ohms, I'll just mark that down. Our current is coming through, going through this resistor, or I'm sorry, our voltage is coming through this resistor, coming down, and then it's going to the path of least resistance. So it is going through the anode and cathode of the diode all the way to this circuit, path of least resistance, goes back around to ground. Now with the resist, and basically this is reading the difference in voltage. With this voltage being higher here and lower here, it's finding the path of least resistance, obviously, and going through the ground. We will later find that doing the voltage drop or the voltage divider equation, you'll see the reason why that is once we start plugging in the numbers. So first we're going to do the equation for the voltage divider for ambient light. AL, that's the abbreviation for ambient light. Here's our equation: total voltage times resistor, which is RN, we'll say, over total resistance. So we plug in our numbers. Total voltage, 10 volts, times the resistor for R1, so which is 1K ohms, over total resistance, which we're doing ambient light, so for this rung right here, this would be 2,000 ohms or 2K ohms. Cross these out. It's 10 times 1 over 2, which is 10 over 2, equals 5. So we got 5 volts on our resistor 1. And that is going to be the same for our photo eye at ambient light, because we are at 1K ohms as well, because the two 1Ks equal the 2K. So now what we're going to do is we're going to do when it's complete darkness, when we got our 30,000 ohms. So we'll write complete, abbreviation CD, complete darkness. Let's write our equation. $10 volts times 30,000, so 30K for our darkness resistance. Total resistance for the 2 is 31K. Cross these, 10 times 30 is 3,000 over 3,100. Gives us our 0.963 8 volts. So that's our voltage over our photo eye complete darkness, which is 30K. Now, to find out our other resistor, all you simply do is you take the 10 volts total voltage, subtract the 0.968 volts, gives you 9.032 volts. And there you go. There would be your R1. So here's your R2 and your R1. So we'll write it neatly here. R1 is 9.032 volts, 0.968 volts. Right there's your two voltage values for these. Now you can obviously see that with your 9 volts coming through your resistor 1 during when this is complete darkness, path of least resistance, voltage is going to flow through here over to here, because this is only 5 volts right here. Forgot to put those on there. So it's going to come here. These are 5 volts and path of least resistance, and there you go. So now we're going to find the current. All right, so time it. Pause it for a second. Okay, now we're going to be showing the current through here, through these rungs. So current equals voltage over resistance. That's basic Ohm's law. So these two combined is 2K. So we got 2K over that is our resistance. So we got 2000 over 10 volts, which is our total voltage, gives us 0.005 amps, and that would be for our first rung, and that would be during ambient lighting. Now with total darkness or complete darkness, once again we go back to our equation, and it's going to be 10 volts over 31,000 ohms equals 0.00032 amps, and that's going to be the amps during the complete darkness with all the resistance. So that should kind of sum it up. So let's watch that one more time with the... Actually, let's kill the lights. You want to pause it for a second? Yep. So our light's on. Now if you watch... You still recording? And then light goes off during when the lights come on.